Good day, everyone. In this experiment, we will discuss the determination of total surface moisture content of aggregates. This laboratory activity is important in construction materials testing because moisture greatly affects the quality and performance of concrete mixtures. Aggregates such as sand and gravel naturally contain water. Some of this water is absorbed inside the particles, while some remain on the surface. Determining the total and surface moisture content helps engineers adjust the amount of water used in concrete mixing to maintain the desired strength and durability. In this experiment, fine and coarse aggregates are tested by measuring their weight before and after oven drying. The difference in weight is then used to calculate the moisture content of the aggregates. The main objective of this experiment is to determine the percentages of total moisture content and surface moisture content in samples of fine and coarse aggregates. At the end of the activity, the students should be able to first, understand how to determine the total and surface moisture content of aggregates. Second, expand their knowledge about the importance of moisture content in construction materials. And lastly, apply the proper techniques and skills in determining moisture content for professional engineering practice. Moisture content is one of the most important properties of aggregates used in concrete production. Total moisture content refers to the total amount of water present in the aggregate. This includes both the water absorbed inside the pores of the material and the water found on the surface of the particles. On the other hand, surface moisture content refers only to the water present on the surface of the aggregate particles. It is obtained by subtracting the absorption value from the total moisture content. This experiment is performed by weighing the aggregate samples before and after drying them inside an oven at a temperature of 110 degrees Celsius. The drying process removes all moisture from the aggregates. The difference between the initial weight and the dry weight represents the amount of moisture originally present in the sample. Accurate measurement is very important during the experiment. Errors in weighing or incomplete drying may affect the reliability of the computed results. Understanding the moisture condition of aggregates is essential because too much or too little water in concrete can affect workability, strength, durability, and overall structural performance. The materials and equipment used in this experiment include gravel, sand, oven, weighing scale, and containers. These materials were used to prepare, dry, and measure the aggregate samples during the experiment. First, prepare a minimum of 2,000 grams of coarse aggregate with a maximum size of 25 millimeters and 500 grams of fine aggregates. Second, weigh the prepared samples and record their initial weight as known. Third, dry the samples inside an oven at 110 degrees Celsius for approximately 3 hours, or until a constant weight is achieved. After drying, allow the samples to cool. Fourth, weigh the dried samples and record the final dry weight as W2. Lastly, calculate the total moisture content using the formula. Total moisture content equals W1 minus W2 over W2 times 100. The surface moisture content is then calculated by subtracting the absorption value from the total moisture content. Surface moisture content equals total moisture content minus absorption. These calculations help determine the amount of excess water present in the aggregates. Based on a conducted experiment, the total and surface moisture contents of both fine and coarse aggregates were successfully determined. Based on a conducted experiment, the total and surface moisture contents of both fine and coarse aggregates were successfully determined. The results showed that fine aggregates, or sand, contained higher surface moisture compared to coarse aggregates, or gravel. This means that sand can retain more water on its surface because of its smaller particle size and larger surface area. The experiment also emphasized the importance of proper moisture correction in concrete mixing. Excess water may weaken concrete and reduce durability, while insufficient water can affect workability and proper bonding of materials. Overall, this experiment helps students understand the importance of moisture content testing and its role in producing strong, durable, and high-quality concrete for engineering and construction applications. Thank you for watching.